All right, so now we're down to application problems for inequality. Example 24 says a stone is catapulted vertically upwards with a velocity of 25 meters per second. Okay. The distance traveled by the stone after t seconds is given by s is equal to 25t minus 5t squared. How long does its height exceed 30 meters? So the distance, since the stone is catapulted vertically upwards, the height essentially is the distance. So what the question is asking us is, for how long is the height, which is 25t minus 5t squared, greater than or equal, not greater than or equal to, says exceed. So it's greater than 30 meters. So this is a quadratic inequality. Let's go minus 5t squared plus 25t is greater than 30. If I divide the entire inequality by minus 5, I'm going to get minus 5t squared over minus 5 plus 25t over minus 5 is less than 30 over minus 5. So if you divide an inequality by a negative number, you must change the inequality sign. So what we end up with is t squared minus 5t is less than minus 6. So t squared minus 5t plus 6 is less than 0. So this is a quadratic inequality. To solve it, the first thing I'm going to do is I'm going to find the critical values. Now, the critical values are the values of x for which t squared minus 5t plus 6 is equal to 0. Factorizing, I get 3, 2, minus, minus. So t minus 2 is equal to 0, or t minus 3 is equal to 0. So t is equal to 2, or t is equal to 3. Using a graphical approach, the critical values are the x-intercepts, which is 2 and 3. And what I want are the values of t, for which t squared minus 5t plus 6. So this is s is equal to, or not s. This is, let us say, this is t squared minus 5t plus 6. So that's the graph. And the values for which the graph is less than 0 are the values of t between here. So our solution is t is less than 3 and at the same time is greater than 2. All right, let's see what are the units. T is in seconds. So in other words, t exceeds, the height exceeds 30 meters for the period between 2 seconds and 3 seconds. Between x is less than 3 and x is greater than 2, the height of the stone, yes, which is catapulted vertically would exceed or would be higher than 30 meters. So example 25 says the cost in TT dollars of producing X carnival costumes is given by C is equal to minus 2x squared plus 1,400x plus 16,000. And this is for X less than or equal to 300, but greater than or equal to 0. Now, X being the number of carnival costume. A costume designer wants to keep his cost less than TT $166,000 for the year 2013. What is the maximum number of costumes? So what is the maximum number of costumes can be produced within this investment? All right, so the amount of money that he has to spend must be less than or equal to 166,000. So the cost of producing the costumes, C, which is minus 2x squared plus 1,400x plus 16,000 must be less than or equal to 166,000. Why less than or equal to? Because you can spend all the money that you have or spend less than it, but you can't spend more. All right, so solving. Let's start by dividing the entire inequality by minus 2. So minus 2x squared minus 2 plus 1,400x minus 2 plus 16,000 minus 2 is greater than or equal to 166 minus 2. Remember, if you divide both sides of an inequality by a negative number, you must change. If you divide an inequality by a negative number, you must change the inequality sign. So now we have x squared minus 700x minus 8,000 is greater than or equal to minus 83,000. So x squared minus 700x minus 8,000 plus 83,000 is greater than or equal to 0. So I have x squared minus 700x plus, I think this is what, 75,000? 75,000 is greater than or equal to 0. So I'm not sure about this factorizing, so let's use the quadratic formula. All right, to solve x squared minus 700x plus 75,000 is equal to 0. So x would be equal to minus 700 plus or minus the square root of minus 700 squared minus 4 times 1 times 75,000 all over 2 times a, which is 1. So this is 700 plus or minus the square root of all right, so 700 squared that is 490,000 minus 4 times 75,000. This is 300,000 all over 2. This is 700 plus or minus the square root of 190,000 all over 2. So 700 square root of all over 2. All right. Let's find the square root of 1900, 190,000. So this is 700 plus or minus 436 all over 2. So x would be equal to 700 plus 436 over 2, or 700 436 over 2. So x is equal to this is 568, or x is equal to this is 132. And what we want are the values of x, which these are the values of x which is equal to 0. All right, so if I did this, yeah, 568, 132. So my values of x would be between here somewhere. So x is less than or equal to 568, or greater than or equal to 132. So what did the question ask? They asked for what is the maximum number of costume? So I would say the maximum number of costume would be what? 568. So x max, x being the number of costume, is 568. So just looking back, let us check over and see if we did anything wrong. Oh yeah, we did something wrong. Here, we're looking for values of x that makes x squared minus 700x plus 75,000 greater than or equal to 0. So what we did was less than or equal to 0. So let's fix this. All right, so drawing back our quadratic. Sorry. This is still 568. And this is 132. It must be, so the value of x must be what? Greater than our solution. These are the values of x. Or that is the section of the graph that is greater than 0. So x must be greater than or equal to 568, or x must be less than or equal to 132. Now, this answer must be rejected. And the basic reason for that is because we were told in the question that x must be less than or equal to 300. So x greater than 568 would be rejected. And so looking at this, the maximum number of costumes, which is x max, would be equal to 132. The maximum number of costumes is 132.